Hello, everyone, and welcome back to yet another edition of the Calsoft podcast, your premier source for discussions on all things tech. I'm your host Shantanu Pant, and with me today is Mohsin Khazi. Hi, Mohsin.
Hey Shantanu,
Welcome to the show, Mohsin.
thank you.
So, before we start, a quick introduction. Mohsin has over 14 years of experience in building world class solutions for data centers. He's worked in storage, networking, virtualization, and even cloud computing. He's practically a one stop shop for any tech company. So let's jump right into today's topic, chaos engineering. Recently, Mohsen designed and developed a proprietary chaos engineering framework for a Fortune 500 company to stabilize their enterprise cloud solution. So, chaos engineering is a fairly new concept, right, Mohsen?
I would say, though it was started long back, but it's becoming popular from past couple of years.
Why it's gaining so much popularity among tech companies right now?
Absolutely, Shantanu. In the new age IT infrastructure, what we're having, and also the modern applications, there is an increase requirement for higher availabilities. So we usually measures availability in terms of number of nights. So we used to see the system up till 99.99s or 99.999 as a five nines. But there is an increased requirement to increase the availability of the system. Uh, Also make the system more resilient. As you know, a lot of businesses these days turning to be looking at the digitization and getting digitized. So the impact of any sort of downtime or any kind of outages in the system leads to severe impacts, and primarily the impacts are on the revenue aspect as well as the user experience, and also of course on the company's reputation. These are the few parameters, but the overall the need to have higher available system with a lesser downtime is increasing. Just to quote a recent example of Facebook, you must be aware of Facebook's outage recently happened. As per the Facebook's root cause analysis, this was just a faulty misconfiguration of their backbone router, which led to the offline of various Facebook services, including WhatsApp and Instagram as well. So the impact of that, if you see, though it was a faulty misconfiguration, the outage lasted for 6 hours, and it led to revenue losses to Facebook anywhere between 60 million to 100 million, and also it had a huge impact on the Mark Zuckerberg's personal wealth as well. Close to 6 billion loss is observed on his personal wealth due to the sharp decline of Facebook stocks by 5%. So that's the kind of impact we see for any companies if they hit a downtime, not only in terms of revenue and the user experiences, and also how quickly the system can jump back if they see. So such situations definitely leads to a lot of revenue losses. If I can give some more stats on the other impacts, or the other observed impacts of the downtime in infrastructure. So as per the CA technology survey, so companies loses anywhere around $26.5 billion revenue due to the IT downtime. Similarly, for Fortune 100 companies, per hour revenue loss is anywhere between 500K to 1 million. That's the kind of impact downtime has. And chaos engineering plays a significant role in addressing issues around the downtime. So frankly, building any system which can be 100% uptime is still not practical. Whether you use any costly hardware, or you use a very well vetted software with put in a lot of efforts on the design and development, but still systems are prone to failure. So it's good to identify the probable failure upfront. So chaos engineering is such practice where you can identify the potential failures in the system by doing certain experiments. Once you identify those failures, you can then easily observe the response of the system, how well the system is resilient to such faults, whether it can absorb, or what sort of enhancement or improvisation required in the system. So given this context, so a lot of companies are focusing, apart from the regular traditional testing, they are also focusing more on adopting chaos engineering, and that's the reason we see a lot of companies are getting into the practice of doing the chaos engineering.
Can you tell us what exactly is chaos engineering?
Yeah, sure. So, if I go by the standard chaos engineering definition from the chaos community, it's basically a discipline of experimenting on a system in order to build the confidence in the system's capability to handle any turbulent conditions in the production. Uh, in simple terms, if I explain, so chaos engineering is disciplined approach to proactively identify failures by injecting failures in the system in a planned fashion. And just to make it more clearer, if I go by Gremlin's analogy of chaos engineering, and I think this is relevant in the current situation as well. We all are aware of the vaccination shots we are taking for COVID, right? So chaos engineering we can look at. I mean, in the same analogy aspect. So uh, it's basically like the way vaccine works, wherein we actually inject the harmful entities into our body so that our body can develop an immunity and prevent illness. It's in the same fashion. We inject faults in a very controlled fashion into a given system so that we can identify the system's response to such faults and also improvise the system based on its response. There are core objectives chaos engineering focuses on, which it especially focuses on measuring the resiliency of the system and the availability, as we discussed earlier, and also the overall capability of the system for any mishap or in the system. So chaos engineering focuses on measuring these three objectives.
So, how did you get started with this? Because this is a relatively obscure field.
That's right. Yeah, that's a good question. Actually, at Calsoft, a couple of years back, we had one of our esteemed customer came up with a problem statement where they were building their enterprise cloud. We are still, working on this solution for them. So where the requirement was, they wanted to have a higher availability for this enterprise application because they were hosting mission critical applications on this enterprise cloud. So they wanted us to come up with a framework which can test the availability of this. Uh, Even though at that time their system was anywhere between supporting the 4 nines of availability. The 52 minutes, I think, roughly around is the downtime. So they wanted to achieve the higher availability. So they were seeking help from us to come up with a framework to measure this. So that's when I was exploring and I came across a tool called Chaos Monkey, which is open sourced by Netflix. And that's when did the further exploration. I realized that Netflix is the pioneer in chaos engineering, uh, and they basically when in around the time frame of 2010 and 11 when they were migrating their on-prem data center to AWS, they wanted also to test these three parameters of resiliency, availability, and capability of their system, so that there is no any impact on the streaming when they actually move from physical server to virtualized servers of the AWS. So that's when they developed this tool called Chaos Monkey, which they open source and which is actively still maintained on the community. That's the time frame. I started exploring on the chaos engineering, and since then we developed a bunch of solutions for our customers.
Chaos engineering seems to be extremely useful in terms of resilience, like improving your website's resilience. But what are the other advantages of setting up chaos engineering in your firm?
Yeah, sure. There are a bunch of benefits or the key benefits the chaos engineering offers. To begin with, of course, the revenue is the prime focus. So it chaos engineering helps you to minimize the revenue losses, as we discussed in the Facebook case, right? So the kind of revenue losses can be drastically reduced with the chaos engineering by upfront identifying the failures. Similarly, increasing the availability of your mission critical applications with the help of chaos engineering, so that your system is highly available, and you can, with the number of nines, you can decide what, and you can predict what would be the downtime throughout the year. So chaos engineering helps you to measure as well as increase the availability. Apart from that, since you inject the failures upfront, it helps you to and you also study the potential failures upfront. So it helps you to have a reduced maintenance window in a production environment whenever you see a downtime. So if you have a mitigation plan available, so you can have a reduced window wherein quickly you can fix or have a workaround for it. Apart from that, it increases the customer trust. Simply as your system is highly available, so definitely the customer trust will be increasing with the help of chaos engineering. Apart from that, your overall incident logging, wherein your support teams and the SREs putting a lot of efforts, those can be drastically reduced with the help of chaos engineering, and also the cost associated with the SREs and the support teams. Also, we can come up with the improvised system design for a couple of our customers. We actually implemented chaos engineering at their test environment level or the staging environment, wherein we can identify the failures and enhance the system design so that the failures are minimized. Excuse me. And also uh, the faster recovery of applications once you identify the failures. So it helps you to your be it your infrastructure or to your application quickly recover from any failures. So those are the few key benefits I would say from the chaos engineering we can you can talk about.
That sounds extremely useful for pretty much any and every kind of company. So, given that Netflix came out with it, or rather developed the concept that many years ago, which other companies practice chaos engineering right now?
Oh, there are there's a huge list of companies which are opting chaos engineering practice. To name the few big players in the industry, the likes of Google, Microsoft, Amazon, LinkedIn, and Uber and AT&T, Yahoo, and Dropbox are the few technical giants who are already using the chaos engineering. Apart from that, we see a lot of adoption in the banking and finance sector where the requirement on the availability is higher. Banks like Morgan Stanley and National Australia Bank. So these banks are also adopting the chaos engineering. And actually now even the cloud services, the hyperscalers like AWS and Azure, now they have a default service available for the chaos engineering. Anyone who's hosting their applications on these cloud, they can make use of these services. It's built in with these hyperscalers. In my opinion, any distributed system, uh, any ISV who's into the infrastructure or in the application development, uh, if they are into the distributed systems or if they are migrating to the cloud or if they are undergoing digital transformation and also uh, if they are developing cloud native applications on the microservices and Kubernetes based, for all these scenarios, chaos engineering is a perfect fit to uncover the potential failures.
So, getting to the crux of the discussion, if I were planning to set up a chaos engineering practice, what would be the typical steps involved?
That's a good question, and purely as you mentioned, it's the core technical aspect of it. Uh, at Calsoft, we propose five stage workflow for the chaos engineering, and I think pretty much a majority of the companies follows around the same similar stages. So to begin with, in the chaos engineering, we define the steady state. That's actually the way you define the normal behavior of the system. And in the second stage, we hypothesize, wherein we define the measurable metrics like latency of the system, the expected latency of the system, bandwidth, throughput, and other metrics which are specifically interested for that use case. So such metrics will be defined in the hypothesis. And in the next stage, we actually run the experiment wherein we inject the fault in the system. This is ideally done on the production environment, but as I said earlier, we have also done it for customers who were where the system was in staging or test or POC kind of environment. There also we injected the faults. So basically, the third stage I'm talking about is where we actually inject the failures into the system. So if you are doing it in production, then we recommend the chaos engineer who's doing it should be very cognizant of the fact of blast radius being determined here. So we need to make sure that the impact of fault what we are injecting in the production environment is pretty much confined and controlled and shouldn't affect the customers in live or in production who are using it. So once we actually run the experiment, the next stage is actually the verification, wherein we capture the uh, response of the system when the fault is injected. And we also, once we have this captured data, so we compare the differences between the proposed hypothesis what we created and the what's the actual matrices we are seeing. And with that, we identify the potential failures in the verification stage. Once the potential failures are identified in the next stage, we propose the fixes for it, and also in case no, if it's not at the fix at code level, we also proposes the mitigation plan for the type of or the nature of the failures we see. So this is the overall phase, and we also recommend to run this in a very continuous manner, wherein these faults can be injected at a scheduled period, or it can be random based on the various use case. So to make it effectively to execute this workflow, it's better to execute it with an automation framework rather than doing it manual, because manual may not be effective to uh, you know simulate the failures randomly. So automation frameworks here do a very good job, wherein we can randomly inject the faults, and also the automation can help you to capture the key parameters of the system, so that with that you can verify and then propose for the improvement. That's the overall workflow involved in the chaos engineering, and also the recommendations what we propose.
But I wanted to ask, given the incredibly wide variety of ways in which faults can occur, what
Mhm.
kind of sample faults do you inject into these systems? Like, which are the most common ones, or which are the ones that cause the most harm?
Yeah, sure. Let me quickly run through the most or the typical faults we inject, and these are focused purely on the infrastructure. As I said, the system word I'm using in the chaos engineering can be for a entire infrastructure, or it could be at application, or it could be at both the levels. So the typical faults could be, and also these are the real-time faults we often see in a real system. So hence these becomes kind of mandatory faults to have. So faults like compute server failing, right? It could be any reason, but simulating a compute failure is must have in the faults. Similarly, operating system or the hypervisor which is running on the server. So these crashing. So we simulate the operating system or hypervisor crash. And the other common condition which leads to fault we see is the resource starvation. Typically the CPU and memory starvation overloading. Right? We simulate such CPU and memory overload to see systems behavior. Also, failing the virtual machines and the container instance where various services are running is another fault. And on the network side, there could be multiple again. So disabling or failing the network interface card, or on the switch side, disabling the switch port, or uh, inducing a switch failure altogether. So these are the few network failures we can inject. Similarly, on the storage side, we can forcefully delete a volume. We can forcefully fail a disk in a particular storage node. And if there are storage nodes in HA, then we can fail one particular storage node and see how well the storage can cope up for a particular storage node failure. If it's a metro cluster kind of architecture, then this makes more sense. And at times, we bring down the entire cluster to see how system responds when the cluster goes down. So these are the few sample faults I would say, kind of commonly we use across various customers or the solutions. And again, we have customer specific, which I'm not capturing here, but these are the few typical sample faults.
What kind of tools would you recommend for our listeners?
Yeah, again, a good question. Anybody who wants to get started with the chaos engineering and get their hands dirty, uh, there are a bunch of tools now available. Back when we started, we hardly had only the Netflix open source tools, but now there are a bunch of tools available. Uh, I categorize them in two categories. One is all the open source tools available. We'll discuss them in a minute. And also there are requirement to build the proprietary frameworks as well, like the way we did it for a couple of our customers. The reason to go for proprietary is customers have their own specific requirements and the specifications and the way they measure the system. So those vary a lot, and having a proprietary framework gives a lot more control to customize that. In that category, also would like to highlight about the Calsoft chaos engineering tool. It's an accelerated IP Calsoft developed, which can be readily used by our customers. This is basically very easy to use with an intuitive UI, and also it has integrated monitoring solutions and can be extended to other monitoring solution which customers are using, and it can also be extended and customized easily. So that's another option with which customers can get started with the chaos engineering. To give a quick brief about the open source chaos engineering tools, there is Chaos Monkey, we discussed some time back. So this is basically the Netflix tool. Netflix, the Chaos Monkey tool is open source by Netflix. So this basically does the it power off the compute instance which is running that particular service. And apart from that, there is the Simian Army, which is a suite of uh, different tools, again open sourced by Netflix. The tools include Chaos Monkey, Chaos Gorilla, Latency Monkey, Conformity Monkey, etc. So in case of Chaos Gorilla, interestingly, the entire regions, it brings down the entire region. So there are huge bunch of different tools which we can use. The another one which is significant and it's not been covered here is the Chaos Toolkit. That's again has lot of drivers and wide variety of support to various infrastructure like AWS, Azure, on-prem, Kubernetes. So it covers wide variety of infrastructures. Apart from that, Gremlin is doing a lot good in the space where they provide both licensed and the free version for the chaos engineering, where they help to set up and control the chaos testing with their tool. And we also have Pumbaa, which is, if you're interested in testing more on the network side, so I recommend this. So it does the network evolution for the chaos engineering, and this is again focused on the Docker kind of environment. Mangle is another interesting tool. This is open source by VMware. This supports the new or variety of systems like Kubernetes, Docker, and of course the vCenter from VMware. And in fact, any remote machine which you can access from SSH, it helps you to test the chaos engineering on these different systems, and it's also easy to use in my opinion. Litmus is another tool which is again specific to Kubernetes with stateful workloads. If that's the use case or that's the kind of system we're building to test it. So Litmus is another good tool. So these are the bunch of tools on the open source side, and also there are proprietary tools can be developed. So with this, anybody can quickly get started on the chaos experiments.
So that is quite frankly a fantastic starting point for anybody who's interested in chaos engineering. Well, Mohsin, I think that's all the time we have for today. It's quite clear that chaos engineering has a lot of advantages, and I, for one, can't wait to see how it progresses. Thank you so much for being a part of this conversation, and I hope to see you on this podcast again soon.
Definitely, Shantanu. Thank you. Thanks for having me.
Well, this has been the Calsoft podcast featuring Mohsin Khazi. This was a fascinating look into chaos engineering, and I'm sure it's going to go places. Stay tuned for future podcasts where we explore the latest tech concepts and advancements. Thank you for listening.